Welcome to Wolf Magic classes, where mastering NCERT concepts are made easy and effective. Today, we are going to discuss some of the questions of Chapter 1 Matter in Our Surroundings. So, we are going to discuss some of the questions from the book bag. Okay, students? So, let's dive into today's concept. First question, what we are going to discuss here is convert the following temperature to Celsius scale. Have you all remembered that if you want to convert a Kelvin to Celsius, what we have learned? If you want to convert a Kelvin into Celsius, Kelvin to Celsius means we need to subtract 273 from the given temperature, because 0 degrees Celsius is nothing but 273 Kelvin. So I want to convert 300 Kelvin into Celsius. So what I have did here, 300 minus 273 will give us a value of degree Celsius 27. 573 minus 273 gives 300 degree Celsius. So simply we have to subtract 273 from the given temperature value when you convert Kelvin to Celsius. If Celsius to Kelvin means we have to add 273. Kelvin to Celsius means minus 273, Celsius to Kelvin means plus 273. Okay, children, with the given value. Next question, what is the physical state of water at 250 degrees Celsius? We all know that at 250 degrees Celsius, the water will be completely converted into a vapor. So it's we can see only the gaseous state. So it is a gaseous state beyond its boiling point. But at 100 degrees Celsius, we have seen at 100 degrees Celsius, it is not the complete gaseous state. No, it is a transition state where we can see water as well as some gaseous water vapors also there. So the answer is it is at the transition state as the water is at its boiling point. Water is at its boiling point. It doesn't complete it. So hence it would be present in both liquid and gaseous state. Next one, for any substance, why does the temperature remains constant during the change of state? I can hear your answer, ma'am, latent heat. Yes, good. It is due to latent heat. As the heat is supplied to increase the temperature of the substance, is used up to transform the state of matter of substance. Hence, the temperature stays constant. We have seen, no, when we take a beaker, we have placed some ice cubes and a thermometer to check the reading. Temperature has been given. What we have seen, it's a melting point. Melting point is nothing but the temperature, minimum temperature at which the first ice cube starts melting. After that, what happens? Slowly all other ice cubes starts melting. Till that, there will no increase in temperature. So why? Because the heat I am giving is used to convert the ice into water. So it is used up there. So it is hidden. That's why it is known as latent heat. So it is due to latent heat, as the heat supplied to increase the temperature of the substance is used up to transform the state of matter. Hence the temperature stays constant. Something which is used somewhere else. Okay. Suggest a method to liquefy atmospheric gases. I already told you. For in our household things, LPG gases and all, we used to get it in the form of liquids, not in a gaseous form. So it can be achieved either by increasing the pressure or decreasing the temperature, which ultimately leads to the reduction of space between the molecules. What happened? The space, when you increase the pressure, the space between the molecules get decreased. So it can be converted into a liquid. In the same as it, when you decrease the pressure also. When you increase the pressure and decrease the temperature or decrease the temperature, what happens? Why the gas is converted into liquid? Because the space between the molecules is reduced. That's why we already know solids are tightly packed, liquids are loosely packed, gases are very loosely packed. So automatically this distance reduces and it is converted into a liquid state. Okay. That's why we get all our gases. For example, in a hospitals and all, nitrogen cylinders, oxygen cylinders and all are carried in this manner because it is easy for us to transport. Why does a desert cooler cool better on a hot, dry day? It is because the temperature is high and less humid on the hot, dry day, so enabling better evaporation. So high level of this evaporation provide better cooling effects. That means what is in by desert cooler? It is nothing but our cooler, dear. Okay. So you know what? Do you all know that why we place AC on the top? Why it can't be placed at the bottom? Yes, I can hear you. Always listen, children. Hot air moves up, cold air moves down because they are heavy. So I want AC. AC helps us to chill down the air, right? So it becomes heavy and it comes down. So if I keep AC at the bottom, what happens? The cool air will go down only. So we are at the top. We can't experience that cooler. That's why AC is placed at the top. But room heaters, where you will place? On the top or at the bottom? Because hot air rises up. So it should be placed at the bottom. So what they are asking here is why the coolers are good during the dry days or hot dry days? Because humidity. We have learned now less humidity increases the evaporation because humidity is nothing but the amount of water vapor present in the atmosphere. So if the air contains less humid, there is no water particles at it. It is very dry, so that we can experience the direct heat. So automatically what happens? If you on the cooler, it will sprinkle the water and the water will be converted into vapor soon and evaporation causes cooling. That is the answer here. It is because the temperature is high, so it is less humid, it is dry, so it leads to better evaporation. Evaporation will be faster, and better evaporation leads to cooling effect. Is it clear? So, two things we are learning here: less humid, rate of evaporation will be high. Second one, evaporation leads to cooling. How does the water kept in an earthen pot become cool during summer? You have seen in olden days and all they used to make a mud pot. Nowadays it is trending now, right? Instead of using drinking fridge water, it is very helpful. So an earthen pot is porous in nature. It has many tiny holes because it's made up of clay, sand. No, it has many tiny pores on it. So with through that tiny pores, the water will penetrate out and undergo evaporation. So the process of evaporation, what happens? It takes up the energy from the surroundings, right? So as a result, evaporation leads to cooling. That's why it leads the chillness towards water. That's it. Is it clear? But here the answer is evaporation requires energy which is contributed by the water in the pot, as a result of which water turns cooler. So where the energy comes from the water, so it gives it back the cooling towards the water. Okay. Why does our palm feel cold when we put on some acetone or petrol or petroleum perfume, not perfume on it? So because they also evaporation causes cooling. So evaporation, it takes energy from my hand, right? So that energy is now, it is not vacant, it is vacant over there. So it leads to cooling. Energy is in the form of heat. It is what happens here. It is taken place in the form of heat. That's why it took all my heat energy. So the remaining will be chilled down. Why are we able to sip hot tea or milk faster from a saucer rather than a cup? Another thing, larger increase in surface area increases the evaporation. So saucer has large surface area than a cup, promoting quicker evaporation. Hence the tea or milk in a saucer cools down faster. Why? What type of clothes should we wear in summer? You all know very well. It is preferred to wear light colored cotton clothes because light color reflects heat and cotton materials have pores that absorb sweat, and it also facilitate evaporation. So evaporation causes cooling on skin. Convert the following temperature to Celsius scale. So again from Kelvin to Celsius only. So minus 273. So 20 degrees Celsius, 470, 197 degrees Celsius. Convert, see here, Celsius to Kelvin. So we need to add. So already I have told you Kelvin to Celsius means minus 273. Okay. Children, please be careful while writing the units. Okay, from Celsius to Kelvin means plus 273. Okay. So give reason for the following observation. Naphthalene ball disappears with time without leaving any solid. Yes, because it undergoes sublimation. It is directly converted to a gaseous state. Not it doesn't go into the intermediate liquid state. So we can get the smell of perfume while sitting several meters away. What is the reason here? Molecules of air move at higher speed and have large intermolecular spaces, no? So perfumes comprise a substance that are volatile. Here there is no temperature at all. You can ask me, ma'am, you told me increase in temperature increases the kinetic energy, the particles. We learned that hot sizzling food only the smell will reach away, no? But then what happens here? Because perfume contain a volatile substance which scatters quickly in air. That is the nature of the volatile substance. Okay? Hence, we are able to smell perfume sitting several meters away. Arrange the following in increasing orders of force of attraction between the particles: water, sugar, oxygen. We all know very well oxygen is a gas, sugar is a solid, water is a liquid. So, which is, they ask us to listen carefully, look at the question, increasing order. So, it should start from the least. So, gases are least force of attraction. So first oxygen, then liquids water, then solid sugar. Okay. What is the physical state of water at 25 degrees Celsius? Water will be only in the liquid form. 0 degrees Celsius, both solid and liquid, because there will be ice as well as water. 100 degree, now you know, both liquid and gaseous state. So give two reasons to justify water at room temperature is a liquid. So water persists as a liquid at room temperature since its melting point is lower than the room temperature and its boiling point is 100 degrees higher. That's why it is a liquid at room temperature. An iron almirah is a solid at room temperature. Why? Because its melting and boiling point are above the, listen carefully, water is at room temperature because melting point is lower than the room temperature and boiling is higher. So the in between, melting is solid state, here boiling is gaseous state. So in between it is existing. That's why it is known as it is existing as a liquid. Here the room temperature of water does not have a fixed shape and flows to fit the container shape. As a result, water is a liquid at room temperature. Almirah, because its melting point and boiling points are above the room temperature. That's why it is always in a solid at temperature. They have rigid shape, high density. As a result, room temperature of almirah is a solid. Why is ice at 273 is more effective in cooling than water at same temperature? Yes, here we have the answer. Latent heat. Yes. Ice will absorb heat energy or latent heat from the medium to overcome the fusion and transform into water. So as we know very well, during that Celsius itself, during that Kelvin itself, during that temperature, both ice as well as liquid exist, but that ice has extra energy. So ice has greater cooling effect than the water at the same temperature, since water does not absorb the effects of heat from the medium. We have learned now, during that melting state, ice will be there. What is that? Liquid also will be there. Which will be greater effect? Ice. In the same manner, during the boiling state, vapors will be there, liquids also will be there. Because they have the hidden heat in them, hidden energy in them. That's why they are able to be more effective. Then what about the water? From ice to water. The water has been converted, no? It took up the energy. Here, the energy is stored there. It needs to be converted. So, it has greater effect. What produces more severe burns? Boiling water or steam? You know very well. Exothermic. What is in by exothermic reaction? It is because an exothermic reaction means releases high amount of heat. Exothermic means it releases the heat. Endothermic means it absorbs the heat.